Hello and welcome to my channel. Today we are going to continue with another Golang exercise, and we are going to simulate a running songs playlist, and then we are going to suggest some other songs based on user input. We're not going to focus on making the best solution. There are many ways in which such a problem could be solved, many algorithms, many ideas. We are just going to focus on learning more Golang syntax. So let's start. We're going to create, as usual, a main.go file. And then we are going to declare our package here. After this, we're going to declare the main function, which is the entry point. As usual, we need an entry point into our Golang application, which is the main function. I'm going to now paste in some mock data. Right. So what we have is a variable called selection, which is an array of songs, and where each song has a title property, a number of likes, and a category which it belongs to. Now let's see exactly how we would build such a structure, because this song type does not exist yet, so we need to create it. Let's go to our file here. Of course, when we save, it complains that there is no song type. We need to create it. Touch song.go. So here we will declare, and we will say type song struct, and we will say it has a title, which is a string. It has a category, which is a string, and it has a number of likes, which is an int. We need also to declare the package that this type will belong to. And what we also need to do is to add a comment. Let's actually make the category an enum, which is a bit more meaningful than a string. So let's say we're going to have type song category, just call it category, and it's going to be an int. And then we will say, we will simulate a enum. Golang does not have enums per se, but we can simulate them. Const with a bunch of constants. Let's say pop category equal iota, and what iota represents is just a sequence of integer constants, and when you declare it like this, it starts with 0. You can also declare it like +1, and then it starts with 1, and so on. Then we have jazz, and then we have rock. So now that we have this, so then this category is now defined, and then we could say that our songs category is actually of type category, so that we can use some constants. We can use these constants throughout our application instead of actual meaningless integers. Okay. It wants a comment here as well. Okay. We will also need a toString method on this category. Let's say we have func. On the type category, we make an extension method, and we say it returns a string. So then we make a switch on the category, and then in the case of jazz, we return jazz. In the case of pop, we return pop. In the case of rock, we return rock. All right, and if there is a default, we return empty string. All right. So now we can do something like song.category.toString, and then we will get the enum value instead of the integer. Okay, going back to our program, we would like to, so we have a selection of songs, which is an array of objects of type song. We have two songs from each category, 2 rock songs, 2 jazz, and 2 pop. And we want to simulate running a playlist of these songs, and then the user is asked to like or dislike them. And then based on the input, the user is suggested a song from the same category. And then if the whole playlist was listened to twice, then the playlist is going to be restarted. We will have to use this selection, and let's create a type called playlist. So we say touch playlist.go. We declare the package as usual. We declare our playlist. The playlist would have an array of songs. Actually an array of pointers to songs. And then you will have a property that gives us exactly what is playing at any given moment. So the song that is currently playing. Okay. Let's add a comment here. Let's actually make this array of songs an actual type, which is called, let's say, song list. And then what that refers to is an array of songs. And then we can say that this is a song list. The reason why we did this is so that we can attach some extension methods on this type. Because you cannot add extension methods on the array, but if you create a type that refers to the array, then you can actually extend this type with further methods. So let's add. Okay, now we will need to say something in our program like, let's, for example, let's create a new playlist. So we would have something like new playlist from selection, right? Now, there are no constructors in Golang, but we can simulate them with some functions. Of course, this function does not exist. It's not defined, but we will define it right now. We'll say func new playlist. And what this takes as argument is an array of songs. And it returns a pointer to a playlist. So that essentially it plays the role of a constructor. So we can create a playlist. Then we can inject these songs. We can insert these songs into the playlist. So we iterate through the songs that we passed as argument to this function. And then we just say p.songs is append p.songs and give me the address of each song. Right? So then what we end up with is simply, as we said, a list of an array of pointers to song structs. Okay. So now we have some sort of a constructor, new playlist. So then when we declare this, now let's do something with this playlist. Let's, for example, start with just printing, just to see what songs do we have. We would need to declare this function. Let's declare it right now. So we would have a func on the playlist pointer, which is called print. And then we would print line, let's say, let's print a title and current playlist is, we iterate the songs in the playlist and then we just print them. We could say song song.print. This method does not exist right now, so let's create it. Type song has no field, pointer to song has no field or method print. Let's actually create this method as well. So basically, when we print the playlist, we just want to see each song that it contains. So we will add a print method to the song struct. So we will simply say print is going to simply show the song with its details. So let's say message equals formatted printf, and then here we show some properties of the song. So then we say title, category, and then we say the number of likes, and this would be formatted with %d. So we would have s.title, s.category, toString. Remember, we made a toString method so that we get the actual value, not instead of the integer. And then we have the number of likes. Then we will just format the print line message. And that's all that this function should do. So now we are printing these. We have forgotten to return something here. We should return p. No, this is a pointer, so we should return the address to p. Okay, now it's better. Something is wrong here as well. I is declared but not used. Yeah, we simply do not need to make any use of the iterator here, so we just replace it with an underscore. All we need is the song. Okay. Let's go back to our main program. So now if we run this very simplistic program, we see a bunch of songs, right? We see current playlist is, and then we have the list of songs, and then we have the number of likes for each song. Okay. Let's actually do something more interesting now with this playlist. So we will have to make use of something called scanner to read from the user's standard input. So we would say scanner is buff.io dot new scanner, and then receives input from standard input, scans on standard input. We will have to create a ticker in order to be able to repeat an operation at regular intervals. So we will just simulate something like a ticker. Ticker is time.new ticker, and let's say 50 time.50 milliseconds. So every 50 milliseconds do something, and we will see exactly what we will do right now. So now for range ticker dot, right, so these should have been imported. Now when we say for range, we should have ticker.c. We try to fetch the next song to play from the playlist. So let me say next is playlist.get next to play. And of course this function does not exist, so we will have to write it, and then, you know, we just play the next song. So let's actually write these methods. We don't have this. We need to declare them. So if we go to playlist, let's start with the function play. So let's say a function on the playlist pointer, which is called play, and then it receives a song as argument, and then we say playlist that now playing equals s, right? And then we will just format exactly what we are playing, and I'm just gonna paste this in again. So I'm just going to say now playing this song with this title, this song, this title with this category, press 1 to like or dislike, or 0 to dislike, to string. Right. We should also create the get next to play function. Func playlist get next to play, and what this returns is a pointer to a song. And here we will first of all create a song list which stores songs of another category than the ones that are currently playing. So I will explain it in a second. Other categ songs of type song list, and then we will have to see if something is currently playing. So if p.nowPlaying exists, which means it's not nil, then we will just iterate the songs and find something from the same category. For range p.songs, we iterate all the songs in a playlist. So we have if the title of this song is not the currently playing song, so if we don't want to repeat the exact same song that's playing already, and the song has less than 2 likes, then if the category of the song is the same with the category of what's currently playing, then we want to return this song. The idea being that if you like a song, you want to hear more from the same category. However, if the category is different, we want to add it to this song list of other category songs. Append other category songs s. Okay. So what happens now is, now if the current category was listened to twice, so if the current category was listened to twice, try another category. So if it enters on this condition, that means it was still not liked twice, so then we can return a song from the same category. But if it was liked already, chances are people want to hear something else because they listened to it twice already. So then we say if the length of the other category songs is greater than 0, then we should return a random of that. And right now we do not have this function, but we should add it. Let's extend the song list with a random function to give us a random from that song list. So we want to extend this type with this random function, and it gives us a song from that list. Right. So first of all, if there is nothing in there, then we will get nothing. However, we need to return random if there are songs in the list. So we will say ran.seed of time.now Unix nano. What this does. So when we are going to make use of math rand. What this does is it makes sure. So this seed ensures we get a random value every time it's evaluated, right? And then let's take a random position from our song list. Random position would be a rand.int and from based on the length of the songs, and then we just return songs of random position. Right. So now we have a getting back to our method of getting the next to play. We have a random function, but we still need to return something here in case all the songs in the playlist have been listened to already. Then we should just return p.songs.random. This function is there because remember, songs was of type song list, and we just added an extension function on. We just added an extension function called random on the song list. So now we can access it also for the songs in the playlist. So this is how we can extend arrays with other functionality by just assigning them to a type. Right. We should also probably, like, if we are going to restart the playlist, it's completely irrelevant at this point what songs were liked how many times, because we would probably want to reset the number of likes. So let's just do that. Reset likes. We do not have this function, but we should create it right now. So let's just go and create it. Function on a playlist pointer. So we say reset likes. Then we should do basically an iteration of p.songs, and then we simply set the property likes to 0. That's all. We have created a playlist. We have simulated the constructor. We have printed the playlist by printing every song in the playlist. We have then created a method that gets us the next song to play. So what we need to do right now is to ask the user, do you like this song that it's playing right now, or do you not like it? So let's try to simulate that. For scanner.scan, this will give us the input of the user. If scanner.text equals X, let's give the user also an opportunity to exit our program. Then let's show exiting player, and then always the exit with 0. So there was no error when we are exiting. It was just a user decision to exit the program. But if it's not X, if the user presses, for example, 1, then that means the user liked the song. Option, user option, choice, let's call it choice. And this is string convert.parse int scanner.text. So we are parsing the input as a integer. we have now this variable called choice contains the user's input. So we will say, let's make a function that that writes to that property. So we go to the song and we create an extension function which is called set liked, and it receives a boolean which determines whether it was liked or not. So if it was liked, likes will be increased. Else, likes will be decreased. Okay. Yeah, we should also prevent, because with this, likes can go below 0 and it makes no sense. So we should just prevent that. So else, you know, in case the s.likes is above 0, only then decrease it, because we're not interested in. Okay. So basically, this is currently playing from here. We started, playlist is now playing the next song. So now this next song can receive the user's feedback. And then if it was liked, it means that choice was 1, right? As simple as that. If it was not liked, then this evaluates to false. Let's run our little program and see what happens with all this. Go, run, everything.go. Right, so now we have our current playlists. All of them start with 0 likes. Now playing Miles Davis. Let's say we press 1. Oh, we have a problem here. We have a little bug. We never exit this. Okay. We never exit this. We never exit the for which takes the user's input. So we have two fors here. One is the scanner. So what happens is that we need to stop this asking for the user's option, because we now have it. We don't need to ask it all the time. One thing we could do is to print the playlist again after we have the user's input. Okay. Let's exit. Let's retry. Go, run, everything.go. Okay, so all the songs again start with 0 likes. Let's press 1. We like this song. So now this got incremented in the list. Okay. Since this was the rock category and it was liked, we have been, our playlist has started another song from the same category. So let's say we like this too. Okay, now it's going to choose the same category. So then we have 2 likes here, 1 like here. Now we have 2 likes now for both. So our getNextToPlay method chose, remember we said if, we chose from the same category only if the likes is below 2. Let's say we like this too. Of course, we can also dislike this one. So it has 1 like, but we dislike it. Now it has 0 likes again. So you get the point. One thing we can do here is we have 2 likes, 0, 2 likes. It's kind of hard to follow, right? We could do a sorting here. So we could say, so let's stop this. We could say here, whenever this runs and whenever we print it here, sort it for me based on the number of likes, because it's easier to follow through when you look in the console. But how do we sort a playlist? You know, these are not primitive. It does not contain some primitive types. A playlist is something we just made up. So that means we need to create a custom sort implementation. We need to tell Golang what does it mean when a song is compared with another song, right? So how do we do that? So let's we want a sort function here, but there is no sort on the type pointer to playlist. So let's create this. in our sorter.go. So we add another file. Of course, this belongs to the same package. And then how do we do this? So we know that we want to sort by, you need to choose a criteria but by which you want to sort. So we say, yeah, we want to sort by the number of likes, but we need to tell Golang how this will go. So we need to create this type by likes, and this is on the playlist. And then we need to implement this sort interface, so to speak. So we need to have 3 functions that belong to the sorting. These functions are let's say b by likes, length, which returns an integer, and then we just return length of songs. Then we need to implement the swap method. Swap and b int. So how does that happen? That happens because b.songs from position A and b.songs from position B equals b.songs from position B and b.songs from position A. So it's basically literally swapping them. And then we need a third function to complete our implementation of the sorting interface. And then we'll have on this type that we created, which means less. When is a song less than another, so to speak? Between A and B, which are the indexes. So we say that b.songs of A that likes is greater than b.songs B that likes. So first of all, this should return a bool, and I made a mistake here, so now it makes a bit more sense. Now our method of sorting would be on the playlist object. We would have func sort, and how do we sort them? We sort by likes on this. The sort package is implemented. Okay, the problem is that we are using the same argument, so let's rename this as, let's say, BPS. It was confusing with this integer. Right, BPS. Right, now we have implemented a custom comparer. So again, how do we do that? We create a type, which is our comparer. Then we declare the 3 methods on it, which are length, swap, and less. Basically, this is the gist of it. This creates the possibility of sorting a struct. we should see, because we have declared, we have called sort here. Now, whenever we have set, we have given our input for each song, there should be a sorting based on the number of likes for these items. Let's see. Go run everything.go. 0 likes, all of them. We like it. So now this is on top. We like this one too. So now, as you can see, they are all sorted by likes. They are no longer scattered, so it's a bit easier to follow through what's happening with this application. Now it just goes through all the songs, and now that we have liked everything twice, when we like this one, everything is being resetted. This is because we are calling inside our next to play here the reset likes method. And that was the exercise. I hope you had fun. Comments below. Have a nice day.